Hey there, folks. So, last episode we went through and we started getting set up an external heat or local heat source, I should say. That'll be things like a campfire. We got most of that set up, but we do have a few things to finish up here, and I do want to also start work on the statline component to work with this and both this and our ambient world temperature. So, just quickly though, between episodes, I want to cover a couple of things. I did go through and did some cleanup on the header file. I just went through, added in some categories, default values for the enable disable text. So the first thing I want to do in here is regarding our particle source. So down here in our interact, I want to add in a control for that. So if and by that I mean turning it on and off. So if is valid particle system, particle emitter, sorry, particle emitter. Activate, deactivate. That's the one. So here's if it's active, turn off the emitter, set it to inactive. Otherwise, we're going to activate. And that's an easy enough change to do there. What else did I want to do in here? There's some other... Oh, I wanted to do this as part of begin play. Set tick function enable. Oh, that was this one here. If is valid particle system emitter, sorry, and B is active, we're going to activate the emitter. And then there is one final one, which is the update from save. We don't have that here because that's something that was defined in the TF actor that we are just inheriting. So we are going to override that. And all we're going to do here is copy that begin play. And the reason being for this is if you've saved the game and let's say you had the fire, you had started a fire. Well, you want that fire to be lit when you start the game. Particle system is going to be working. But initially, it's going to start with the begin play, and then we're going to update that save information. Once that's happened, it's going to say it's on, but the emitter isn't going to be active. So we're going to save all of this. And as you can see, I did launch from Visual Studio, so I'm going to do a quick live code compile here. This shouldn't be too much because it was only that one file that we really did any changes in. I say that and it's going to take forever. While that's happening, though, I will bring over my content browser. Come on. Really? There we go. And where is it? SA Megapack. So in here, I did pull over a particle system. Oh, live code succeeded. And that's not going to work because it's a Niagara system, I bet. Let's open up our blueprint here because I don't have that open. And Let's see, are you gonna let me assign? Where'd you go? There you are. And it's using particles. Okay. Yeah. So we're gonna have to change that to a Niagara system because, well, I prefer to use Niagara. So let's have a look. All right, well, I can't find it there. Let's open a, see if we can find it here. UE5, C++, Niagara. Okay, let's have a look here. C. You would think this would be the first thing that came up. Oh, so public dependencies. So we are going to need to add that. Means we're going to need to rebuild our project. So just quickly to cover what this is. Public dependencies are it's modules, things like that, that you need access to within your code. Without that, you're not going to be able to access Niagara. So what I'm going to do is I'm going to close out of this. Going to close out of the editor, move this out of the way. Now your public dependencies are actually defined. Is it this one? No, no, it's which one? There it is. So within your source, your project, your build. And you can see in here, much like, pull this over, scroll this down a bit, so we can get them both on the screen. So we have core, core U object, input, input core. We have enhanced input. That's something with Unreal Engine 5. We want to add Niagara in there as well. So we're going to do that. Now we need to rebuild the whole project. So I'm going to, and this is something I recommend whenever you need to do a full rebuild, do it this way. So clean the project. That is just going to delete everything that was compiled through Visual Studio. You can see it's go through, clean started, whatever. This is going to give you a clean slate, or as close to a clean slate as you can get. You can do it to the whole solution. If you want to do that, it's going to take a lot longer. But because this only affects your project, so in this case, the fall, that's the only one we need to worry about. So I'm going to do a rebuild on that. Now this is going to take some time because we did that whole clean solution. But whenever you're doing things like adding a module, you want to do that because that's going to pull in absolutely everything you need and make sure it's pulled in where it's needed. So with that, I'm going to pause the video and I will be back as soon as that is done. Okay, so it didn't actually take as long as I thought. 109 seconds, so not even 2 minutes to go through, but one did fail. So, what failed? Inventory component. Inventory component line 81. It's CPP, so it's the source file. Well, that wouldn't have failed, so. It's not throwing. Build tool. That's up to date. Apparently something needed to be rebuilt. But anyway, so now that that's done, so let's pull up that web page again. I just scrolled down. Niagara component. So throw that in here. And the other thing I had seen while I was quickly reading over that page is down here. It's not a pointer, so. Oh no, it is. Okay. Right. So. Okay, we've said build that. Is that going to throw an error now? Nope, it worked. It just didn't see it. All right, so with that, copy this property class. Make sure I get these right. Niagara system. We're going to call this particle emitter, and we're going to get rid of the particle system. And add the semicolon in so that it doesn't complain about stuff there. Now this is going to be down to your personal preference if you want to use Niagara or if you want to use particle systems. Since Niagara came out officially, I've stuck with Niagara. So what we're going to do in here is we're going to try a build because it's saying it doesn't exist. Okay, what was the other include? Let's try those two and see. Yeah, those failed. Oh, we got particle system there. Let's try and fix that. That might have been my issue. I don't think it's should be a Niagara system. No, it's a Niagara component, and that's why. So this is something else you may find as you're looking at things online. It's not always going to match exactly what you need. So what we need is a Niagara component. Single U, please. Pointer to an incomplete class. Let's try this again. Rebuild. There we go. Okay, so that's now built. I'm going to get rid of the function library, actually, because we don't need that. This may take a little while to clear up, because let's go to definition here. Go to, not definition, I want a declaration. Definition. There we go. So yeah, it's in the Niagara component header file is where this is all going to be what we're after. So this is correct here. There's no errors. And these two, this is just IntelliSense being a royal pain in the butt. Everything else here is still valid. So now that that built fine, we're going to launch in the editor. And apparently it's doing some rebuild. Oh, no, maybe not. Pull this over. Let's see how long it takes. Now we added that in. It's building pretty quick. So while this builds, one thing I want to mention, do not compare your build times to my build times. I may not have the best system, but I have tried tailoring it to code compilation just because I do it for a living. So you may find your builds are a lot slower. At the same time, you may find your builds are a lot quicker because it's not a gaming PC that I'm working on. So with that though, let's open up our blueprint quickly. And blueprints dev. Open that up. Let's get our content browser back up, and we'll go find our particle system. I'm going to select that and just move this out of the way. And particle emitter. Oh, is that not going to let me? I bet I've screwed this up because I haven't worked with Niagara at a code level. Do I have to rebuild this whole blueprint? No, I'm just going to go fire test. Yeah, that was that. Okay, so we're going to... no, actually, it's this one. I'll open you up as well. Just for quick ease here, I'm going to grab my world mesh, select that in the content browser. World mesh, set you there. Heat zone. You have I'm going to copy the scale and paste that scale, and then the particle emitter, it's now letting me pick a particle system. So let's drag that in. There we go. And you can see right now, if we zoom in, it's a little funky. One thing you'll notice, you can't scale Niagara. Like Y scale of 11, only certain things will scale. I'll rephrase that. You can see the smoke scaled, but drop that down to 1. What I'm going to do is I'm just going to raise this up a little bit. You're going to actually raise up? Yes, you are. We want you there, just roughly. I'm going to compile that. And that is the fire test. So find you. So one of the tricks you can do here is, so make sure your new blueprint you want is selected. Over here on your actor, right click, replace selected actor with, well, in this case, I just replaced the floor, because no, not place, replace. There we go. All right, so now one other thing we're going to want to do. Actually, no, it should stop at begin play. Let's check to see. Or we're going to have code errors. Okay, it is still running. Oh, and I don't have the heat fall off added in there either. But yeah, so you can see enable text is light, disable text is douse. Added that to a debug, so let's compile that, save. And then, actually, nope. Sorry, that's not what I wanted to do. Auto activate, compile that, viewport. There we go. That was the one, auto activate. And what that is the particle system turns itself on. You don't want that. That was actually one I was completely forgetting about. So Now if we play, we're hitting our tick because we have that valid heat source. Whereas before, the heat fall off. Before we didn't hit that because this function here is now working. That's turning our tick off. That's something you can add to any actors that you have, that you only want the tick logic to work under certain conditions. That actually means this isn't needed now that we fixed that. So I'm going to leave that in until I stop this session, but this is something you can add in. And basically it's like, okay, we can't use this tick behavior because we're missing something. Turn your tick off. So I'm going to drop this breakpoint though. No, I don't want to add a new one. So I'm still getting used to the increased font size. So I'm going to switch over to first person, run over. And now you can see we're getting text when we hit it, light and douse, and our fire starts up. Now you can expand this further. You can add a light source in if you want. I would recommend, if you do that, do it through blueprints, because we've already taken what should be a pretty basic actor and added quite a lot there. And actually we'll do that. So we're going to open this up, bring it over, and point light. Actually, we need to make some changes here. So compile and save this. We're actually going to close out of this. I'm going to close out of the editor for now. Yes, we want to save those. So what we're going to do is nope, I can do that in the private, I believe. U function blueprint native void on interact BP on interaction BP, yep. And then just because you have to do it with these functions, need to add the implementation in there. So now IntelliSense should throw both of these aren't defined. I'm hoping. Yeah, there we go. You do not, private function cannot be. Okay, so yeah, we do have to put that in public. It's been a while since I've done those. As one, I'd be worried about wanting to keep public. Keep private. So quick action. We're going to create that. And then we're literally just going to call the blueprint version of it. And I'm going to grab this function here. Where's our interact? And just before our return, and the reason why we're doing it just before the return is we want it to be after all of our code is executed, and then we carry through to the blueprint stuff. So also, as I mentioned, we don't actually need this anymore because our actor will not tick if it is not got a valid particle system. And right here, yeah, no, we still want that. I was just thinking, do we still need this? But yeah, no, that's particle emitter. So we're going to build again. And this will be the last change we're making here, and we're going to move over to working on our stateline component. Oh, something failed. What did I miss? Oh, I didn't add the semicolon at the end of those lines because I'm not with it today. Okay, that should work this time. And yes, as I've said many times, these are the silly mistakes that developers make while they're working, and you seem to never see that in a tutorial video. So I'm just reading over the All right, so now that we've got that, we're going to go into our blueprint actor for this campfire. We can actually get rid of campfire. And I'm going to rename this dev BP campfire test. Okay, so for this, I'm going to add a point light. And you want to drag that up. Now, normally you'd think your light source will be down here, but it's going to cause some weird shadow effect. So I just bring it up there. And in your construction script, get scale. Get relative 3D scale, set scale, set relative 3D scale, and this should, if the math is right, compile that. No, what is it? The attenuation radius. That's the one. And sphere radius. Okay. Sphere radius. Okay, is that the one we want? Okay, obviously not. So we need to adjust that by a factor of quite a bit. Because, yeah, you notice it won't. Times by, let's say, 4. Compile and save that. Select a point light. I'm going to set that to the center, actually, so we can see. So 4 is... No, not in Blender. About half, so let's change that to 8. It's a little too much, so 7.5. Ooh, 7, I think, is the actual magic number there. Yeah, so 7 is. Anyway, so now that we've got that, let's go back to perspective. Let's move our light up a little bit. And then was it intensity? Yeah, so we want to start our intensity at 0. And then color. Just make a basic orange color here. Orangey yellow. And that works for now. And again, this is just very basic. I'm getting sidetracked, but I'm pretty good at that. So in our event graph, we're going to go over here, overrideable functions on interaction BP. B is act. Did I not expose that? Visible anywhere, blueprint read only. B is activated. B is, why is that not exposed? Visible anywhere, blueprint read only. That is not making sense. That should be is activated. Okay, that's different. I haven't had to do it that way before. And all we're going to do here is a branch. Get our point light intensity. Actually, I don't even need to do that. So select float based on this. If it is active, we want the intensity at, we're going to do 1,000. If it's not active, we're going to do 0. So yeah, this is weird. I wonder if that's something they've done recently in 5.4. So now we've done that, we're going to come out here and play an editor. TikTok. Switch over to first person for ease. Okay. So I'm going to wait for it to get dark so you can really see this, but apparently I messed with the light source. But there you can see it's got a light range around it, so we're going to stop there. It was just barely catching that cube. But if we do this, we grab our heat zone and we scale it up. Oh, no. This is the one we want there, right? No. Okay. That code I wrote, blueprint I put in there to scale that isn't working. So I'm just going to get rid of it. Oh, no, that's radius. I know why. That's that one there. Get scaled sphere radius. That's why. Let's try that again. So heat zone, you can see they're both hitting in the middle of the cube. Scale this down. We select the point light. It's just hitting the edge of the cube. I'm actually going to re-hide the there so you can see heat zone. Yeah. Okay, let's try that again. We're going to go over first person. I thought I hidden that. Well, either way, go over, hit light. You can see we're getting, where's a good fall off point we can use. Right here at the edge of this one, you can just see, was that third line in? Right here is a good point. So oh, and that's huge. That's why, because we don't need that multiply in there, I bet. So actually, just to correct, that is removing this out because I was using the wrong radius. Yeah, there we go. That is exactly what we want. So I'll light that. And now we should see it doesn't have anywhere near as far of a fall off. Yeah, so it is just, it doesn't even fill the whole circle for the heat zone. Now, if we take that heat zone and we scale it up, we should notice, actually scale up on all axes. Are you going to work? There you go. Now, that is one thing I've noticed. To trigger the construction script, you need to do something here. Or something in the details panel of the root actor itself. Simply scaling this for some odd reason doesn't trigger that. So we're going to quickly play again. And this will be the last thing we do, and then we'll start adding some code to our stat line. All right, that's dark. Sorry, I just was reading a message on my phone quick. Light that up. Still doesn't have much fall off. So, what have I messed up there? Heat zone, hidden game. Heat zone. Hidden in game. Why is that showing? Oh no, hidden in game. We want that to be true. Sorry, I'm being blind. Yeah, sorry, I was completely backwards there. Okay, so anyways, here, get rid of that. Attenuation radius. Well, at this point, I'm not going to mess around with that too much more. That is a visual item you would work on later on once you're trying to do like a beauty pass. So we've got the basic setup here. I went even a little further and added that light, which I didn't intend to do. Something like that, like I said, I recommend doing on in blueprints instead of in code, just because you can do it in code. We're doing it with our chrono manager, but little tiny things like this, you don't need to write code for. You can use blueprints. This is perfectly fine. If you want to do this in code, go right ahead. But now that we've done that, we need to start looking at our statline component. So we're done in here now, so I'm going to close out of the editor. Yeah, I'm going to save that. So obviously there wasn't actually a problem there. We're done with that. We're going to leave the heat source actor open. We're going to open up our statline component, both the header and the source file. Let's minimize all of these and clean this up quickly because that's going to annoy me now I've seen it. So we want to leave actually our begin play on because there is some code we're going to be adding in there. Yeah, I didn't break it. Actually, no, I will leave that line there. Anyways, so my OCD out of the way for now. I'll deal with that between episodes. So what we're going to want to do is two things. We want our stat lines to subscribe to the temperature change broadcast, if I could speak. But we only want that to be on certain stat lines. So we're going to add a new variable in here. And need to go through and categorize these a bit. But what we're going to do here is down at the bottom, bool. No, we want to edit defaults only one actually. Be concerned about temperature equals true. Now this is it's a very open-ended Boolean there, and the reason being for that is you could have creatures that have a full stat line, but they're not worried about, say, the cold or the heat. Let's take, for example, a fantasy game or a horror game. You have a ghost. Ghosts are going to have some form of a stat line if you want to make them like, say, a fantasy game like Skyrim, but they're not going to be worried about it being cold outside because they're ghosts. They don't feel temperature. So that's the whole purpose of this. That's, again, we're keeping the stat line universal to all characters. So we need to add this in here. So first of all, we're going to use that. Now, actually, I'm going to pragma region temperature. I'm going to start formatting these a bit. Pragma and region. Just because I want to group this up and organize things a little better. Now we want a visible everywhere one. Visible everywhere. It's up here. Float current ambient temp equals 0. And then float current local temp offset equals 0. And then we also want to add in a couple of functions. So the first one we're going to want to add is a public function. We're going to make this blueprint callable. Void adjust ambient, no, not ambient, local temperature offset. There's the one we used. Local temp offset. Local temp offset. Const float reference offset value. We're going to create that definition. And the other one, just because, and again, this is something I do with programming all the time, I've already written some subscription code to a delegate within the regrow harvest actor. So go take a quick look at that. Okay, so you need to find a reference to it. And then you add a dynamic and then the function. So we're going to go take a look at our chrono manager and look specifically at the delegate that we're using. Update temperature, on temp change broadcast current world temp, which is a float. So we need to create a function for that takes a float. And how did we define it in the regrow harvest actor header, actually? On time change, just a U function void. Okay. Void on world temp change. Just actually float val. No, we're going to change the temperature. Temp sure. Because we didn't add any. Yeah. So we're going to do things a little different here. Oh, I didn't define that. These are both very simple ones that we're just going to be calling and doing a value assignment. So and current ambient temp equals temperature. So these two are pretty basic. This is just to get the information over to our stateline component, because we are going to be having our stateline manage all of that. So what we're going to be doing here, though, is doing this, but we're not going to be using a permanent reference to it. So I will show you what that is. ATF Chrono Manager. Chrono equals cast unique. Oh, we're missing a couple of includes in here. So we want include Kismet gameplay statics and the chrono manager. All right, and we don't actually need the class there now. Actually, we can include the header. If chrono is valid chrono. Now, obviously, we're going to fix this, but to do that. And we have an extra, yeah, we have an extra one in there. No, it's still. Is that just IntelliSense being weird? Yeah. Okay, so let's try a quick build on this. So, anyways, well, it did fail. Okay. That tells you how with it I am. I'm trying to bind a float to a time. Wow. So yeah, these again, as I was mentioning a little bit ago, developers make silly mistakes. And that's one right there. I'm like, I'm trying to bind a temperature change to a time change. And this is again why I say build your code often. Now, as your project evolves, you are going to get to a point where the code base takes a long time to compile, and it's not as easy to do that. So, but this is why you focus on getting all the core stuff down, and you get it working now, let's say 75%. That's an approximate value, but you get it working 75%, and then once you've got all of your core things working at, say, 75%, I'll even say 50%, you can go through and then you can do larger portions of work because you're not doing major code changes or anything like that. But anyways, so going to hop into Play in editor, excuse me. I'm going to select our character. We're going to go down to our stateline component. Don't need any of these. So local temp offset is 0, but you can see our ambient temperature is, it's hard to bounce back and forth, but they're matching pretty close. All right, so that part is working. We're going to close out of the editor again. And then the one last thing we want to do is actually in our heat source, and that is in our tick. Get rid of that. Minimize this. So right here, that's what all of this code is for. So a couple of things we need here. We need to get a include for our stat line. Actually, Oh, and by the way, just because I never actually corrected this for not detecting the, or figured it out. I didn't actually look into it yet. Doing that, I'm going to change the array to a TF actor because we already know they have a stat line component. So that shouldn't break anything. but just in case. ATF act. TF act equals. Why is my brain not wanting to do this? Well, I'm trying to do advanced stuff that may not work in Unreal Engine. So, as TF actor, TF character. All right. Okay, sorry. I was trying to do some weird declaration and a validation at the same time. That may not be something that works with Unreal, but so we're adding them in now as a TF character because we're already casting. We may as well. So up here, we're going to go to our TF character header for a second because we have our get stat line component, and in our stat line we added adjust local. So what we can do here is actor get stat line oh, my brain just completely forgot what we called that. Adjust local temp offset applied heat. So I'm going to leave this in for now, but this is just, again, it's a debug value that you'd want to go through and remove. Part of the reason why, well, and that is actually the whole reason why I put that debug in there, so it's very clear to anyone looking at the code, it's for a debug value. And ultimately, what we want to do here is add that in there, and I'm going to cut that, oh, nope, all the way, cut the whole thing. And simplifies it. So again, you can go through and simplify these things as much as you want. I wouldn't personally expect there to be a ton of active heat sources that are like in memory, open, loaded, and ticking. So I'm not too worried about the efficiency of this, but if it does become a known issue, obviously we can adjust that. We already have it only ticking once per second. So we're going to do one final build here. And again, this should be pretty quick, but no, it failed. Oh, where is that? On line 77. Did I miss something? Yes, I did. Oh. I did not want to cast that, but we're going to have to there. That's something I'm going to have to think about. Might need to change it back to just a actor and do some casting here. No, I'm going to leave that as is. Again, if that becomes an efficiency issue, that is something to... Nope. Actually, I'm going to... Let me just put that in there. So this is something else I would suggest as you're going through. If you ever find anything that's like, well, I'm not 100% sure if this is going to be the best way to do it, use a comment, put a note in there like I just did. It's not going to be compiled into your game. Comments are ignored when it's encoded and compiled, but it leaves breadcrumbs. So if you need to, you can go through and clean this up later on. So Anyways, we're getting close to the end here, so we're just going to hit play. I'm not going to select the character, actually. I'm going to go to the campfire to start with. Applied heat is 0. I'm going to run over there, going to light it. So you can see applied heat is 44. So now we're going to go to our character. We're going to go to our stat line. And current local temp offset is 44. Okay, and we back up. It's getting colder, but it doesn't go away. So that's the last thing I wanted to do. And that is just a very quick code change in here. And this is where I added this note because okay, I'm just going to stop this here a second because I want that in IntelliSense. ATF character pointer removed equals actors in range remove single. Is that return? No. No, I'm not going to get that fancy. No, I need to actually, because we need to ensure this actually removed one. So what we're going to do is the same thing we've got here, which again, not a fan. So if not valid as TF character, we don't care, we're just going to return. And the whole reason for this, so as you can see, returns the number of returned elements. Actually, we're going to say greater than 0. No. As TF character, get stat line, adjust local temp offset. We want to set that back to 0. So this is where I intentionally left some incomplete code because I wanted to walk through, because this is some of the things you need to think about when you're writing your code. It's like, oh great, so they've entered, we're going to adjust it as they're standing there. They're going to leave, we're going to stop updating it. Well, the problem is there, as you've seen right at the end, and if I had ran out there really quick, that 1 second tick, like I was 40, and then I ran out really quick, and this tick hadn't happened again, so I left within a second, I'm going to have a permanent temp offset until the next time I enter one of those. So with that, this guarantees it's set to 0. So I'm going to launch back into the editor one more time. We're going to take a quick look to make sure that line of code actually works, and then we will be ending the episode there. Oh, come on. There we go. Play character, because we already know walking in is working. So character, stat line, current local temp offset. Let's switch back to first person. Light it. So we're getting that initial value there. 48, 49. Like there we go. We're at 50, our max there. Step out, and then you can see it had that little negative because we're not clamping it, but we stepped out and it's back to 0. So actually I lied. We're going to fix that clamp issue. Heat multiplier. No, it's not there. It's here. F math clamp. We want to keep that one there. We want it. No, it's inside there. Sorry, 0. And then what did we call the value? I'm not going to show this. I'm just going to max heat value. Well, it's right there. Wow. It's going to be one of those days. So I'm not going to hop in and show you. We've seen a math clamp work, but basically what this means is this value, it's always going to be either 0, well, between 0 or the max heat value. And I did put that right, min max. F math clamp. I'm second guessing myself now. Yeah, min max. Okay. Yeah. So with that, in this episode, we've gone through and we have set up. Why are you? Thank you. Switched over from a particle system to a Niagara system. Technically, this probably should be renamed, but we'll leave it at that. We have gone through and said if our particle system is valid, like we have an actual setup there, we're going to, and it's meant to be activated, we're going to activate the emitter because we turned it off for auto activation. Actually, we're going to do that up here as well, thinking about it. Particle emitter auto. It's not going to let me because IntelliSense. I'll do that once I fix that. So I'll do that between episodes. I'm actually going to go through and turn off auto activate on emitter. We had that in there last. So we have confirmed that if there is no heat fall off value, that this stops the tick function, which is, like I said, you want that. If you have tick logic that is going to completely fail because something is invalid, just turn off your tick. Then it's never going to happen. It helps reduce, well, the frequency of tick actors. We have it here. If it's a valid particle emitter and activated, turn it on. Just covered that. We went through and we updated the tick function itself to now actually pass this information on to the actors in range. This could be multiple ones. That is why for each... Why are you doing that, IntelliSense? Or Visual Studio. But anyway, so with that, each actor gets its distance updated. We are getting it as a percentile from 0 to 1. We are using that to get our fall off value. And then we are taking that, multiplying that fall off value by the max heat to pass that through to the character for a local offset. We expanded our statline component to take both a local offset and a world temperature change. And within there, we also subscribed to the temperature change. And I'm going to go through and do the same thing. Actually, do we have time manager used elsewhere in here? Current document. I actually think I did. Yeah, there is a reason for that. If valid, time manager there is valid. Yeah, so in here there was a reason why we weren't using a one-off. We were keeping a local storage pointer, so we don't have to constantly call this get actor, because that is actually pretty resource intensive. And I recommend trying to avoid doing that wherever possible in anything after your begin play loop. On time change. Yeah, and that is pretty much everything we needed there. So with that though, folks, this has wrapped up this episode of the local temp system, or local temperature actors. Now you could use this to also work in a negative aspect, of it's a cooling one. However, this would need to change because we have a minimum of 0 and a max. And yeah, I'll cover that in the next episode, actually turning this into a cooling actor. I'm trying to think if there's even actually a use for that, though. No, I can't think of any use for that. So with that though, folks, I am going to end this episode here. I'm rambling, so thank you for watching. As always, if you have any comments, questions, concerns, suggestions, please feel free to leave them in the comments below. I do try to respond to every comment I get. As I mentioned before, if there's any like little, what I've been calling bite-sized tutorials, little things you want some help with, or you need some advice on that I could do a short one-off episode on, again, leave it in the comments. If it's something I feel I'm capable of doing, I'll try and create a little tutorial on that. Trying to use those to fill up some of my posting time, because I can't keep doing a video every day of this series. But anyways, folks, thanks for watching, and I will see you in the next episode.